Today we're going to talk about scientific notation, and it's a shorthand way of writing numbers using the powers of 10. All right, so the first thing is the first factor has to be a number that's greater than 1 but less than 10. All right, so if I take a look here at this example, and I have this extremely large number, thousands, millions, billions, trillions. So I have 7,500,000,000,000,000,000. Very, 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 very large number. But I want to write it in a smaller way so I can use it. All of these zeros are called insignificant zeros. So what happens is I am going to move my decimal point over, all the way over, till I only have one digit in front of the decimal point. In this case, it's going to be the 7. I keep any other significant digits, that means any other number other than 0, unless 0 falls between two significant digits as a placeholder. So I'm going to move my decimal point all the way over, and I can do it in groups of 3. 3, 6, 9, 12, 7.5. So I only have one digit in front of the decimal point that is between the number 1 and less than 10, which is 9. 0.5, that is a significant digit, times 10 to the 12th. So these number of places that I move my decimal to the left, that is my exponent for the power of 10. So notice 7 is greater than or equal to 1, but it is less than 10. Let's take a look at an example. About 4,200,000 people visit the Statue of Liberty every year. Write that number in scientific notation. Well, here's the number in standard form. That's why we write our numbers. Okay, so I want it to move over, all the way over, so my decimal point is between the 4 and the 2, 4.2. Only one digit may be in front of the decimal point. Well, how many places did I move the decimal? 1, 2, 3, 4, 5, 6. There's my exponent, 10 to the 6th power. Now, let's try a couple. All right, 54,500,000. Here we go. 1, 2, 3, 4, 5, 6, 7. So my number is 5.45. These are called significant digits times 10 to the 7th power. Look at this one. 1, 2, 3, 4, 5. 7.23 times 10 to the 5th power. And finally, this very long number, thousands, millions, billions, so we have 602 billion becomes 6.02. Why am I going to keep that 0? Well, because it's between the 6 and the 2, so it's holding that place. Times 10 to the 3, 6, 9, 10, 11, to the 11th power. Okay. We can also use scientific notation to write numbers that are very tiny as well as very large. So if I take a look at this number, I can write that by moving it. Again, only one digit can be in front of that decimal point. So 1, 2, 3, 4, 5 places to the right. That is why it is a negative exponent. So it goes between the 7 and the 9 times 10 to the negative 5th. So let's try this one. 1, 2, 3, 4, 2.1 times 10 to the negative 4. Let's try this. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 5 times 10 to the negative 8. Whoa, this one's extremely large, or extremely small actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 8.03 times 10 to the negative 11. Okay. You can change expressions from scientific notation to standard notation. Standard notation is how we write our numbers, by simplifying the product of the two factors first. So let's take a look at what I'm talking about there. Okay, write each number in standard notation. 8.9 times 10 to the 5th. Well, what would that look like? Now we're going the other way. I'm giving it to you in standard form. 10 to the 5th, that's a positive exponent. Your number is going to get greater. 1, 2, 3, 4, 5. 890,000. Here, 2.71 times 10 to the negative 6, that number is going to get much smaller. So if we start here, I'm going to move 6 to the left. 1, 2, 3, 4, 5, 6. All right, let's try a couple. 3.21 times 10 to the 7th, it's a positive exponent, so I am going to go to the right. 1, 2, and I've run out of room. So I have to add, if I have to go 7 places and I've only gone 2, that means I have to add 5 zeros. And then put my comma in. All right, here I'm going to go to the left 8 places. Well, this gives me 1, so how many zeros? 7. 0.1, 2, 3, 4, 5, 6, 7, 5, 9. Take a look here. Write each number in scientific notation. Well, I have 0.37 times 10 to the 7th. That is not in scientific notation, even though you see the exponent. Remember, you can only have one digit in front that has to be between 1 and 9. So that means I have to move it 1 over. I have just made this number get larger. Instead of 37 hundredths, it's now 3 7/10. So this number became larger. That means I have to take off the 1 place off the exponent. So now it's times 10 to the 9th. Here I have 453 1/10 times 10 to the 8th. Now I'm going to move that over 1, 2. So now my number has actually gotten smaller. It was 453, now it's 4. So it's gotten smaller, so I have to add to the exponent. You have to balance this. So let's try this. 16 times 10 to the 5th, well now that's going to be, and I want you to write this number in scientific notation. So 16 times 10 to the 5th is going to be 1.6. Now let's take a look at that. What actually happened? 16 got smaller. It became 1.6. So therefore, I have to add to the exponent. There's that balance. The number became smaller. This has to increase the number of places. Look over here. 0.203 times 10 to the 6th. Well, now I'm going to bring it over there. And now my number is getting larger. So it's going to be 2.03. So if I'm making this number here get larger, that means I have to make the exponent get smaller by the number of places that I moved it. And finally, we're going to order our numbers from least to greatest. And this looks a little scary. We've got all these numbers in using powers of 10. So what I need to do is put them all into standard form, into scientific notation correctly. So this number here is going to move over 1, 2. So my number is getting larger now. It went from 64 thousandths to 6 4/10. It went over 2. I have to take the 2 off. So 8 becomes a 6. This number, 312 times 10 to the 2nd, is going to be 3 12 hundredths. Well, now this got smaller. So I have to add those 2 places onto the exponent. And finally, the last one, 58 hundredths times 10 to the 7th, well, that is going to become 5 8/10 times 10 to the, you're going larger, so we have to take off 1. You moved over 1 place, we have to take off 1. So now they are all in scientific notation, so all you have to do is put them in order of the powers. Well, this is 10 to the 6th, 10 to the 4th, and 10 to the 6th. Well, I'm going from least to greatest. This is obviously the least. That one, and we always write it in the original form, 312 times 10 to the 2nd. Now in between these two, well, they both are times 10 to the 6th, so now I look at the number itself. 5.8, 6.4. Well, that one would come next. So the original form was this, and then finally this one. So just put them in order, look at the powers, and put those in order. Now this gets a little bit tricky, but we're going to break it apart. 3 times 10 to the negative 7 times 9 times 10 to the third. Express the result in scientific notation, and you can do this as well with division. So what I'm going to do is take a look at my numbers here and multiply them. 3 times 9 is 27. Then remember our bases are the same, so our rule was we can add the exponents when we're multiplying or divide them or subtract them if we're dividing. So negative 7 and a positive 3 gives me a negative 4. This number is not in scientific notation, so we have to put it there, and that means we're going to go from 27 to 2.7. Well, what did I do? I made the number actually smaller, so I have to add to the exponent, and I moved it over 1, so negative 4 plus 1, that's where I'm getting that negative 3 from. So let's try one here. 7.1 times 10 to the negative 8 times 8 times 10 to the negative 4. Well, I want to break this up, 7.1 times 8, and I'm going to do 10 to the negative 8 times 10 to the 4. And 7.1 times 8 gives me 56.8 times 10, and that's going to give me to the negative 4. Now, this is not in scientific notation, okay? So we have to make it that way. Move this over 1. My number just got smaller. 56.8 became 5.68 times 10. And now because this, I moved over 1 and made the number smaller, I have to add that 1 to the exponent. So negative 4 plus 1 is negative 3. And that's it. Good luck.